Welcome back to the Quaxys RF Wisdom series. Today, we're diving into another fascinating video. Understanding calibration involves two essential concepts. The first is differentiating between the measured and displayed S parameters. The second is grasping the concept of the reference plane. We will elaborate on these concepts in the following. Firstly, it is crucial to differentiate between what the VNA actually measures and what is displayed. This is because what is measured by the VNA's frontend undergoes processing before being displayed. For example, this processing includes correcting for errors, embedding or de-embedding components, and applying mathematical functions to the measured values. The next concept is the reference plane. As we will see shortly, the reference planes are used to convert the measured phase and insertion loss by the VNA into the displayed phase and insertion loss of the device under test, or, in short, DOT. Calibrating a network analyzer enables the right conversion of the VNA's actual measured S parameters into the displayed S parameters at the reference planes of the device under test. To clarify this, consider the following scenario. Two cables are connected to the network analyzer on one end and to a filter on the other end. The objective is to measure the filter's insertion loss, yet the cables also influence the measurement. For instance, assume the measurement at a certain frequency point, where the VNA sends out a power of -30 dBm at port 1, attenuated by 1 dB due to the first cable, 0.5 dB due to the filter's insertion loss, and another 1 dB by the second cable. The detector at port 4 measures -32.5 dBm. Consequently, the display shows an insertion loss of 2.5 dB at the measurement frequency point. But how can we eliminate the cable's effect on our measurement to assess the filter's insertion loss directly? This is where calibration comes into play. Now, we're going to explain the concept of the reference plane. A network analyzer measurement always occurs at reference planes. With respect to these reference planes, the measured phase and insertion loss are converted into the displayed phase and insertion loss. By default, the reference planes are positioned at the VNA measurement ports. Calibration allows bringing these reference planes to desired locations, namely the ports of the device under test. The location of the reference plane is where the calibration happens using standards such as short, open, and load. We will describe the calibration process in more detail in the next video. After calibration, the power sent and measured by the network analyzer is still the same. However, the network analyzer uses the lookup table generated after the calibration process to convert the measured value to the displayed value. This table summarizes the measured and displayed values before and after calibration. Note that, in addition to S-parameter calibration, the power can also be calibrated using a power sensor. We will talk about these in more detail in the following videos. We appreciate your time. Your support means a lot to us. Please take a moment to hit the like button and consider subscribing for more content. At Quaxys, we deliver top-notch content, offering exceptional courses, books, articles, and expert insights. Stay ahead in your field, distinguish yourself with our hands-on certified courses, and elevate both your knowledge and value in the job market. Join our journey of success and register for one of our transformative courses today.